Can we hear it one more time for Lee Rubin? Yeah! Phenomenal, phenomenal. And how about one more time for the Brass Field Band? Yeah! Thank you so much. So today we're going to talk about whether machines are ready to converse now, and I'm going to try and keep the energy high for you. As a little bit of background, to understand how machines think, we need to take ourselves back a little bit. I'm going to teach you about the history of thought, thinking about thinking. From there, we're going to talk about some of the revolutions that have happened since 2012, 2017 that allow us to deliver these exceptional experiences. And then we're going to talk about where we're going from here. What does this bright future hold? So let's start with a couple titans of thinking in this industry. We're going to talk about Jean Piaget, Seymour Papert, and Hal Abelson, not only because they have fantastic ideas, but because I want you to win when you play Jeopardy with your family. First, Jean Piaget, Swiss philosopher, born in the 1800s, came from a very different time. At this time, people thought that everybody thought the same way. I think the same way as you. Adults think the same way as children. Piaget had this amazing idea that maybe children don't think like grown-ups. Maybe they learn in a slightly different way. And really invented this whole field of epistemology. Epistemology. Does anyone know what that means? It's the theory of how we think. It's the explanation of thought. And he had this very interesting concept of the way of knowing. What would a child's way of knowing in the world be? How would a child learn? What would an adult's way of knowing in the world be? So when you think of Piaget, I want you to think of epistemology, this theory of knowledge. So Piaget had a protege, comes along in the 1920s, Seymour Papert. And Seymour Papert said, okay, people have a different way of thinking. What is the right way for children to be able to learn? And he says, we've got these kind of prototype computers. They can empower children to experiment, explore, and express themselves. And he's got this very interesting concept called constructionism. Constructionism comes from a book he writes in the 80s called Mindstorms. Maybe you've heard of these Lego Mindstorms. What are you doing with these Lego Mindstorms? You're building things yourself. He says in the 80s, when children interact with computers today, they are programmed by the machine. The machine is programming the child. And Papert turns this on its head. He says, what if the children program the machines? Wouldn't that be a better way to learn? So when you think about Papert, I want you to think about constructionism. It's learn by doing, that you will program the machine and get better. And as an aside, the entire field of education technology is built on the foundations of what Papert says in the 80s. Now, those of you that have children, you've used Scratch programming. You've used graphical programming languages. You've got children building their own Minecraft universes, and it's in this way that they learn about the machine and how the construction of knowledge works. And an interesting aside, so he's got this very bizarre device in front of him. This is called the Turtle. And it started as a computer program. It was a little triangle, and you would say, move forward 10. And it would move that triangle in a certain direction. And then you would say, turn 90, and it would turn to the left, and then move forward 20, and it would go. And you could actually make drawings and constructions that were built into a physical machine here. You see a child has made a sort of fish drawing here. And so it was through these turtles, it was through these machines, physical pieces that children could interact with, that they would learn about the way the world works. They would learn about programming. Now, in 2012, Barack Obama became the first president to write a line of computer code. Does anyone know what that computer code was? Some might think, hello world. That's how a lot of computer programs start. You learn a language by learning hello world. No, Barack Obama wrote move forward 100. How inspiring that his first line of code came from the history of Papert and constructivism. All right, Papert has another protege, comes along in the mid-1900s here, Hal Abelson. Hal says, computer science is a terrible name for this business. Computer science is related to computers in the same way that biology is related to microscopes. It really has nothing to do with it. It's a lot closer to art. It's a lot closer to science. It's a lot closer to magic. And so Hal says the way that we can get as many people around the computer as possible, not to have it be this club of nerds just in their computer science world, but how are we going to share this with all of the population, is to create graphical programming languages that everyone can understand and come together to realize how it works. He says programs must be written for people to read, and only incidentally for the machines to execute. The machines are not the focus here. It's about people. It's about having them understand how all of this knowledge comes together. And so I tell you about these three individuals, and we'll do a quick quiz. When you think of Piaget, what are you going to think of? Epistemology, theory of knowledge. When you think about Papert, I want you to think about constructivism, learn by doing. And when you think about Hal Abelson, I want you to think about getting everyone around the table. Can we all come together to create these programs rather than it being something that only a small group of the population is able to do? And I mention these three individuals because I worked very closely with Hal to build graphical programming languages. And so this is the history of knowledge and really the history of the field of artificial intelligence that these individuals have created. Now, there was a giant revolution that happened in 2012, the deep learning revolution. Now, what happened here is that all of the classical knowledge, all of the things that we had learned previously about epistemology, constructivism, getting everybody around the table to make decisions, was kind of thrown out the window. Does anyone know what kind of dog this is? And any guesses? It's difficult, right? This is a Catahoulin leopard dog. Never really heard of that before. And in 2012, this was the question that was on the minds of a lot of researchers. It was classification. There's a dog in the photo. There's a cat in the photo. You've got a stop sign in the photo. Anyone who's used a CAPTCHA, where are the stop signs? Where are the, traffic lights? You've taught these neural networks how to represent and understand what's going on here in the photo. And so if you look at the history of image classification up until 2012, it was actually not too good. Pre-2012, 1 out of every 3 predictions that a machine would make, they would get wrong. But something changed in 2012. It was the advent of these deep neural networks that allowed the machine to get better and better and better over time until in 2015, you see that the machine is actually better than the person. Because I don't know that that's a Catahoulin leopard dog. We're not good at that kind of classification. We don't have all that knowledge at our fingertips. But the machine was able to understand it. And so this was one of the building blocks that allowed us to build bigger and better deep learning neural networks. 2012. Now we get The Empire Strikes Back, Revolution Part 2. 2017. Who's this guy? Bert. The T in BERT here stands for the transformer. And a transformer is just a fancy kind of neural network that has read everything that humans have ever produced. It's read the entire internet. It's read all the books that are out there. It's listened to all the music. It's looked at all of the paintings and drawings and sculpture. It knows everything about what humans have produced. And it has this very interesting concept called self-attention. It's just a fancy word to say it's paying attention to what is meaningful in a sentence, what is meaningful in a picture, what makes pictures unique, what makes sentences unique. And it uses these billions of parameters. It's used the entire construction of the internet, the construction of all of these books, to get a very good understanding of the world. Now, in 2017, BERT was the best transformer that we had. It had 1 billion parameters. Just a little tiny piece here in 2017. By today's standards, GPT-3, which is one of the very modern transformers, it has 178 billion transformer parameters that go into it. And so it's very, very good at paying attention to what is meaningful in conversation, what is meaningful in images. So what can you do with this kind of stuff? Well, it can have conversations with you. It can tell you that its favorite animal is a dog. And you can say, why? Well, because it's loyal and because it's friendly. And you can say, what are 2 reasons that a dog might be in a bad mood? And the machine will tell you, well, it could be hungry or it could be hot. And it makes sense, it's paid attention. It understands what's going on in the conversation. It can even tell you some jokes. Why don't animals have 3 legs? Well, they'd fall over, rim shot. It can also do your homework for you. This is a big problem for teachers nowadays. How do we know whether a student wrote this or whether an AI wrote this? It makes sense, It's paid attention to all of these different documents, all of these different pieces of knowledge that humans have. And if you ask the machine on one day, it would pick one side of the argument. And if you ask the machine on another day, maybe it takes the other side of the argument. But it makes a lot of sense. It seems like there's some intelligence there. Doesn't just stop with language. It can do images too. On the right-hand side, these are some prompts that I asked the machine to generate. On the right-hand side, I wanted to have a painting of a gas station bathroom by Escher. Now, Escher never painted this, but it looks pretty good, It's paid attention to what is that style, what is the brushstroke of Escher, how does it, know how to make these paintings. On the left-hand side, this was 10 wizards filing their taxes via satanic ritual. Wild. The imagination behind this kind of technology to be able to build that. There's only one problem with what it generated here on the left-hand side. I wanted 10 wizards, but it gave me 15 wizards. So there's something that seems to be amiss here in the deep learning that this machine is paying attention to. And it's very obvious when you start to ask for things like a red cube on top of a blue cube. It's kind of getting the idea right, but not quite. It's paid attention, but it doesn't really have the foundational grounding to understand that on top of 10 wizards, that these things have meaning that's more than just a kind of, rough idea of what this might mean. And so there's a bitter lesson here for all the people who are looking at GPT-3 and these modern technologies and thinking that perhaps they can take all their call center recordings and throw it into some magic cauldron, and out comes the talking robot. Very bitter lesson. GPT-3 and these large language models, very creative, they understand nothing. And so when will we be able to actually take these conversations and put them into this magic cauldron? We are not there yet. So what shall we do? Very bitter lesson that we have here. We've thought about where we've come from. Epistemology, constructivism, getting everyone around the table. And we've also got these very gee-whiz machine learning models that seem like they can do things well, but not when they're unconstrained. Not when you give them free rein over the decisions that it should be up to humans to decide. I'll leave you with one last example here. Prompt for the machine. Why is it important to eat socks? It will speak so eloquently around why you should do this. It is the essence of enlightenment. You are tasting the true flavor of the enlightened mind. Can you imagine if that came out of your call center? My goodness. Wild. Think of an agent. Think of the call center agent. They're focused. They're driven to get results for you, for the caller. GPT-3 is the drunk person in the bar. They just want to continue the conversation. They're happy to talk your ear off talk the whole night about nothing. And so at the end of the day, who cares about its ability to understand general purpose questions? There needs to be a collaboration between humans and machines. We need to be able to bring these individuals together and do the best of what humans do from this long lineage of the way that artificial intelligence was dreamed about starting in the late 1800s, and bring that together with some of these amazing models that, really are mind-blowing. I mean, the changes that happened in 2012, the changes that happened in 2017, that's what's enabled all of the success that many of you are seeing in the contact center. It really is inspiring. And so if we can harness this technology, if we can focus it, if we can put the lens on it in the right way, so that you can focus on industries, you can focus on common use cases, you can focus on applications that actually make this useful for business. And so you don't ask the machine, why should I eat socks? you ask the machine to collect an alphanumeric code, collect a VIN number really well, collect an address really well. This is the basis of the powers that we build inside of the replicant thinking machine. If you constrain it in that way and keep it focused, that's how you're going to see success in your contact center. Now, machines are actually better at doing many types of communication. They obviously pick up the phone immediately, so there's no wait time, but you're able to harvest a lot of the unstructured data that all of your callers are getting in the contact center. Think about the IVR. You want to do billing, you want to do sales, you want to do claims. Me, I always just press number 1. Doesn't really matter what I need, it's the easiest way to get to an agent. I press 1, I mash 0, I get to an agent. This is throwing off the data in your contact center. It's a real problem. You say, I know what my callers are calling about. Well, actually, they've been lying to you the whole time. When you think about taking unstructured data and using some clustering algorithms, using some artificial intelligence to be able to give you that harness of the unstructured data, you can really understand the voice of the customer. And not only that, you understand what should I automate next? Hey, I've done billing, I've done sales, and now it looks like people are asking me for claims. We're able to understand that in the true voice of the caller rather than finger in the wind, oh, I think this is what we should automate next. Now, these calls are shorter than we're result-oriented. Meghna talked about this earlier. 50% shorter calls. Amazing. People get in, they get out, exactly what they want, on with their day. You can reserve the agents for the conversations that are going to be building a relationship with the caller. No longer is it just pounding the phones, trying to get through calls, make sure that I can, hit my quota for the hour. You can actually take time as an agent, slow down, build a relationship with the customer. Shorter and more result-oriented calls from a machine. It's testable. It's consistent. We run the conversation the same way every time. Now, this is useful for a number of reasons. First, you want to make a change on your sales floor. What do you do today? What do you do when you want to have the agents do a different, call flow? An email? Maybe it comes as like a pop-up header bar on their CTI integration. It's really slow process to kind of get this change of knowledge spread out over the entire team. With Replicant, edit the script, push it out live, do a 50% A/B test. It's so easy to get this consistent and testable message out to the caller. We're going to talk a little bit later about the bias in some of these AI systems and how you can combat that when you use the models in the right way. I think the real kind of key to understanding the bias is noticing where there is bias in the machine, because you've harvested all this unstructured data and you can really see exactly where your callers are falling off. Do we have certain regions of individuals where we're not understanding what they're saying? Noel is going to give us a fantastic talk about that later. And so we've developed over the years some best practices in automation. It's definitely a partnership between humans and machines. It's a partnership that sort of fuses the art and the science of these together, and it really leverages the strengths of Piaget's epistemology, of Pappert's constructionism, and from all of these modern transformer technologies that are, really, making automatic speech recognition, entity extraction, intent recognition, as good as they can be. And so let's dig into a couple of those keys of automation. Conversation design, so important, something that Meghna touched on earlier. The customer journey, thinking about all of the ways that they might traverse through the system. Did they start with Replicant, or did they come through an IVR, and then they got kicked over to another IVR, and now they've come to us? Understanding that journey, very important to know what the customer needs at that moment. Do you have a continuous improvement process? Are you getting better from every call? Are you making this machine more efficient, more effective with all of the existing calls that have come into your contact center and all of the new calls that you'll get from there? Measurement is very key. I think this is something that a lot of people don't really have visibility into today. They say, I can't actually tell you how many calls we get. We got a lot of queues, we got a lot of numbers. Maybe you don't even have those statistics on hand. And finally, that outbound is a little bit different in the way that it's handled. To dig a little bit more deeply, and maybe this is just something you want to take a picture of and we can talk about it later, but there is a whole theory of how we design these conversations. And it's done by a human hand. This is not something that we leave up to the machine to understand. This is what humans have understood. This is what our team has developed together with you over 5 years of experience now building these different conversations. I'll highlight on just a few here. Trust is key. Trust is the bedrock, one of the 5 C's, I would say, into how do you do conversations well. If you start the call with, "Hi, I'm Jenny, and I can help you with all your problems," you've lied to the customer right off the bat. No, tell them that it's a thinking machine. And if the person pushes back, because I know they will, they're going to say, "I don't want to talk to an agent. I need an agent right now. I've never had a good conversation with a machine." Well, you can give them the "what's in it for me." You can say, "Hey, I'm happy to get you over to that agent. It's going to be a couple minutes there. In the meantime, I think I can help you with what you need. Can I get your name? Can I get your policy number?" There's a little bit of retraining that happens here. There's a little bit of teaching those callers that, hey, this is a new world that we're living in. We can leverage these best practices, the machine learning models of 2012, the machine learning models of 2017. It's only getting better, but it is going to require a little bit of retraining here. On the customer journey, I think you have to consider the whole conversation. Today, you call into an IVR, you press 1, you get through a flow, and then you hang up the phone. Can you continue that conversation? I need to add a new car to my policy. I need to get a proof of insurance, and then my bill is too high. Is the machine smart enough to handle all of those multi-intents, to thread the conversation through to the end? To know that the machine is best handling the first 2 parts of that conversation, but we actually don't want to use the machine to argue the intricacies of the billing platform. And so let's get that over to an agent. Let's make sure that we escalate with context. Let's make sure that that agent has a glanceable way to know who they're speaking with, what's the context of the conversation, how can I resolve this call in a minute instead of the 5 minutes it might take me if I didn't have any of that information. Resolve, resolve, resolve. Don't deflect. Don't say, "Hey, buzz off." We could give you 100% containment by just saying, "Get out of here." That's not going to be a good customer experience for folks. Continuous improvement is very important. I think learning from every call is something that we've realized that it's a learning experience every day. For anyone who's sort of been in the replicant dashboard, listened to the calls go, it's magical to watch these call flows happen. And you learn something with really every call. There's new intents that we find. There's new entities that we know how to extract. There's dialects that people speak. I grew up in West Virginia. We don't say yes and no. We say, "Y'all got it, boss." The first time we heard that, the first time the machine heard "y'all got it, boss," it didn't really know what the answer was. And it said, "Sorry, I didn't catch that. Are you ready to begin?" And the person says, "Yes." Now we make that connection between "y'all got it, boss" and "yes." And every future conversation is going to be able to handle that dialect, is going to be able to handle that accent. Very, very important. The happy path is only the beginning. I wish the customers would always, do the thing that we expect them to do. You need to allow customers to correct themselves, go back. Maybe they want to escalate, come back into the conversation. Whenever you're sort of checking out these platforms, looking at conversational AI, looking at contact center automation, think about what happens off the happy path. Show me a call that went wrong. How did the machine kind of get the call back on track? This is going to be the key to really your automation journey. When it comes to measurement, I think, you talked about this, containment really isn't everything. We like to talk about expected business outcome. This is, did the machine do the right thing, even if the caller asked for something special? For that call I talked about earlier, add a new vehicle to my policy, get a proof of insurance, talk about the bill. Well, the disposition of that call, the outcome of that call, it was an escalation. But is that a problem? No, that was actually good. We handled 2 pieces of information on the call. We escalated to an agent. The agent has a lot of information. They got the context. They were able to finish off that call in a minute rather than 5 minutes. The expected business outcome of that, very positive. So think about the differences between that and containment. Think about the differences between that and deflection. Very important. This last piece here, I think it's very complex to think about outbound. How can you do outbound well? Are you just cold calling people off a sales list? I think you really want to think about, when is there a value add to the conversation? When is this important that we get you on a voice channel? Everybody gets spam calls. Very few people answer their phone from a number that they don't recognize. When are people going to pick up that call? Well, they might pick it up in an emergency roadside use case. I'm on the side of the road. You told me it was going to be 30 minutes until that emergency roadside vehicle arrives. It's been 35 minutes. If you get a call on your phone, you're probably going to pick that up. And so the machine is making these preemptive outbound calls saying, hey, I'm really sorry, the truck, it's a little bit delayed, they're gonna be there in another 15 minutes. And an interesting thing about that call is that sometimes people got bored, they already put their tire on the car. They're already driving away. And so by the time they receive that phone call, they can't text back. They want to pick up that call in the car. They want to use their voice in order to use the communication channel that's best suited for them so that they can say, hey, I'm not even in that spot anymore, and the truck isn't being dispatched to a phantom location that doesn't even have a person in it anymore. So outbound calling can be so impactful, but you've got to be able to do it right. I think another interesting piece of this is being able to navigate IVRs, navigate voicemail. When we place outbound food orders, we call a restaurant. I want to order, 2 tacos. Sometimes there's a machine on the other side of that call. It says, hi, thanks for calling Ben's Taco Shop. Press 1 for orders. We've got to be able to navigate that IVR and sort of press 1, get your way through it. Sometimes it's another machine that takes the inbound side of the order. Now you've got these 2 machines talking to one another. Wild conversations to listen to. I mean, really, really interesting. This feels like, we're standing on the mountain looking at the future 5-10 years down the line where voice is the API. Voice is the communication channel that even machines use to communicate to one another. It's really wild to think about. So I hope today I've given you a little bit of an understanding of where we've come from, some of the real titans of thinking around artificial intelligence, the importance of humans and machines working together. I hope I've enlightened you a little bit on some of these gee whiz models. Maybe check on your kids and see if they're using GPT-3 to do their homework or not. It's a wild world out there. And finally, hope I've highlighted a couple of keys to automation that are going to be so critical to making an impact in your contact center and really overall delighting your customers and giving them a great caller experience. Thank you very much.